Hey everyone, welcome back to our discussion about things you need to know going into science class. Last time we were discussing how to write, and the next few videos are actually going to be more about the mathematics side of things. So ultimately, one of the really special things about science, and the reason why I choose to teach this topic, is because it is so vast. Um, you could spend You could spend a long time just discussing space and the distances between the stars and distance between the Earth and the Moon, um, distance between galaxies. There are incredible, amazing things out there, and science encompasses the study of all those, which is really awesome. And the really cool thing about science is that it's not just about vast distances in the cosmos, but it's also about the tiny microscopic universe as well. And there are entire worlds inside a droplet of water um, that look just amazing and are so minute that you need special devices to see. And beyond that, there are worlds where you can't even see with a microscope when you get down to the atomic level, which is one of the big things we're going to be doing this year is looking at chemistry and what happens at the level that's even beyond what we can see with a microscope, which is so far beyond what we can see with our own eyes. And when you get down to that level of the atomic level, the number of atoms inside a single droplet of water is huge. 5.1 sextillion, which is a lot of zeros, let me tell you. So we need some sort of tool that can allow us to look at huge numbers or very, very small numbers, and that tool is scientific notation. So ultimately, we have a system here that uses the properties of exponents. Um, you may not be familiar with these yet. Some of you have taken Integrated 1. You have heard of exponents and exponent laws. The cool thing about scientific notation is you don't need to know a ton about that to actually work with it. So ultimately, we break apart the number into a few pieces. We have a coefficient, a base, and an exponent. The coefficient is the number that comes in front. There's a multiplication sign, and then there's times 10 to the whatever. Um, the base is always kept at 10. Now, the coefficient can only be a number between 1 and 9. It can't be 0, it can't be 10 or more. You always put the decimal place in a scientific notation number right after the first decimal digit, and that first digit needs to be between 1 and 9. The base that the coefficient is multiplied by is always 10. So when you're actually dealing with exponents inside a math class, you might see 2 to the power of 5 or something like that, 3 to the power of 4. No big deal. For scientific notation, we don't use any of those. We just use factors of 10. And those 10s are multiplied to some number. So what if I had a regular number and I want to turn that number into scientific notation? You would start by putting the decimal after the first non-zero digit, and then you would add times 10 to whatever that number is, and then you would count the number of places that you move the decimal from where it started. And if you're going to the left, you're going to make a positive exponent. That is the number of places you moved. And if you're going to the right, the exponent is going to be negative. So let's do an example here. So let's say you have 125,000. All right. 125,000, I'm going to put the decimal place after the first non-zero digit, which in this case is the 1. So now I have 1.25 effectively. And now I'm going to write my times 10. I got to figure out what the times 10 is to the power of. Well, I moved 1, 2, 3, 4, 5 spaces. So it's going to be 1.25 times 10 to the 5. Let's try going the other direction here. So in this example, we got a really small number, 0.000034. So once again, I'm going to move the decimal place to right after the first non-zero digit, which in this case is the 3. So now it's going to look like 3.4. Well, I need a times 10. So 3.4 times 10 to the something. Well, I moved it 1, 2, 3, 4, 5 times again, but this time I moved 5 times to the other direction. So this is going to be 3.4 times 10 to the negative 5. Of course, sometimes you're going to want to take a number that was scientific and put it into a standard form. And that's actually fairly simple to do. So if the exponent's negative, you're going to move the decimal place to the left as many times as the exponent says to move. Okay? And the right does the opposite thing with the positives. So let's take a look here. And also one other thing, a lot of kids forget to get rid of the times 10. It's something that I see a lot when you're first working with these sorts of things. So make sure that you've multiplied this all out. The times 10 to the whatever is going to be gone. Okay. So my first example here, I've got 3.2 times 10 to the 5. So I'm going to move the decimal place to 5, and I'm going to be moving it 5 to the right, which gives me 320,000. Example 2, I have 1.7 times 10 to the negative 3, so I need to move the other direction. Okay, I'm going to move that decimal place 3 over, and I get 0.0017.